So now, the first one that we have is side, 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 meaning all of its side is congruent. So as we can see here, these two pairs is congruent by side, 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 because this side is congruent to this side is congruent to this side, and this side is congruent to this side. So it is congruent by side, 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 or SSS. So the other one is side angle side, meaning we have two sides and one angle. So we can see here in this example S of SAS that we have two pairs of congruent side and one angle between them who are also congruent. We can say that it is SAS, or side angle side. If the angle is now between those two sides, there is no way that it can be proved as congruent SAS, or side angle side. And our third example is, if we look here, we have an angle, a side, and another angle who are congruent. We call it ASA. There is a key that I have there. Here we have two sides and an angle between, and here we have two angle and a side between. So this is called ASA. And the last one I have is angle side. Again, I would have two angles like I have here, and a right triangle, both side triangle, both 90 degrees. These are still congruent. So the side, which is not between those two angles, it is still congruent. So this is called angle side, or AAS. So if you notice that AAS is similar to ASA. They have both two angles and one side. So if you have one side and two angles, it's either that it's not in between the angles, or outside the two angles, it is still congruent. But in SAS, if the angle is not between those two sides, it is not accepted as congruent. So now we will cite an example. This will be our example. So we have CROWN, or crown. So to solve it, first we have to make our organized statement and reason chart. Here it is. And let's look at the triangle. So it looks like we have to prove that line RN is congruent to line ON. So to prove that, the first proof is that the triangle CRN is congruent to triangle WON. So I see that there are other two given pieces of information. Now we know that triangle CNR is congruent to WNO because of vertical angle theorem. We can complete our shortcut of ASA. So now it means that we successfully proved that CRN is congruent to WON. Now we still have to prove why line RN is congruent to line ON. To prove it, we need a reason. Do you remember the CPCTC? So it is a corresponding parts of triangles and congruence. So to prove line RN is congruent to line ON, we will use CPCTC as our reason. So now we already complete our chart. So hopefully